Very basics. An angle in standard position, and how do we draw this angle? So I'm going to draw a quick grid, and look, it's very basic. There's my grid. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And if you, I'm going to draw a ray. So here's what you usually do. This is the initial side. That's your starting side. And then from the center, there's my ray. And we call this an angle. You count your angles counterclockwise. It's positive if it's counterclockwise, and if you go clockwise, it's negative. This is a Greek symbol. It's called theta. And we usually use theta or phi, or we use Greek symbols just to, it's just like a variable, like an x. So it's positive if it goes counterclockwise, and it's negative if it goes clockwise. Now, one revolution is how many degrees? Yeah. 360 degrees, guys. So one revolution is 360. Does anyone ever wonder where that 360 number came from? Did someone just make it up? Okay, it was kind of, not really. I'm not a history buff, so YouTube, don't get mad at me. So here's what I know from history. Do you guys remember studying the Babylonians? Okay, well, yeah, the Babylonians, I think they were the ones that invented the number 0, because before that they didn't have that. Yeah, I mean, I'm not a history buff, so I don't know. But the Babylonians, I think, were the ones that said, how long did it take Earth to revolve around the sun? So they tried to get it as close as they could to 365. They landed on 360. So that's where they got it from. They did a pretty good job. I mean, it's really 365 and 1/4, right? But they almost got it. So that's where it came from. Now, if I'm 100% wrong, then, be nice to me. But Google it, look at the Babylonians, and see what's up. Okay, having said that, since by the way, we're not going to talk about radians today. We're going to talk about that tomorrow. So since you know that one revolution is 360, that means I can label my grid or my axis like so. This is 0 degrees. Remember, this is 90 degrees because it's a quarter of one revolution. Then this has to be 180 degrees. This has to be 270. And then once I do a full revolution, I am at 360. So if someone tells you, can you show me how 70 degrees looks like, you're going to draw a ray in what quadrant? Yeah, quadrant 1. It doesn't have to be perfect. Make it closer to the y-axis than x-axis, because 70 is closer to 90 than 0. And now we're going to say that is 70. See? If someone tells you to draw an angle 120 degrees, you're going to draw a ray in what quadrant? Yeah. Here's 120 degrees, and it's this right there in blue. Are we okay so far? If someone says 210 degrees, what quadrant is 210 degrees in? Yeah, so 210 degrees will probably be something like, and we're going to say that is 210. Thank you, miss. If someone says 330 degrees, I'm running out of colors here. What quadrant? Not everyone at the same time? Yeah. I ran out of colors there, guys, so I'm sorry. How do we feel? All right, don't freak out when you see negative angles. Remember what we said? If we go clockwise, Chavez, what does clockwise even mean? It's the direction of the clock, guys. So if we go clockwise, here's 0 degrees, negative 90, negative 180, negative 270, and I completed a full revolution, negative 360. Do you see the direction we went? So I'm going to do the same angles, just so you guys can see. What did I do? 70, 120, 210, and 330. All right, let's do negative 70 degrees. What quadrant am I going to be in? Yeah, quadrant 4. You're right. This is negative 70. Then I did 120, so negative 120 is going to be in quadrant 3. That in blue is a negative 120 degrees. If I go negative 210, and then finally negative 330. Nothing crazy, pretty simple, right? What do you think, Abdul Kareem?
Yeah.
Okay. Awesome.
Oh, you said her last. I was so confused. I was like, what the heck?
I hope I said it right. Did I say it correct, miss?
Yeah, you said it right.
All right. Now, there's going to be words like coterminal. Coterminal just means it's the same ray, different angle. Quote unquote. Same ray, different angle. And that's the unofficial definition. Chavez, I don't understand. What does that mean? All right, let me tell you. So this formula here is in radians. We will talk about radians tomorrow. Here is your formula in degrees. So we're going to say phi, that's what that is, phi, is equal to theta plus or minus 360 n. And notice that I put a little degree symbol there. That's how you differentiate between a degree and a radian. They're both angles of rotations, or measurements of rotations. I haven't lost anyone. Am I okay, guys? All right, so we're going to talk about why this formula is. Okay, so let's chat. So here we go. I'm going to draw, let's see, I'm going to draw 390 degrees. So I do a whole revolution, and I'm going to go another 30. So that's going to be a big hint there. 390 degrees. Actually, I should have, oh, well, it's too bad. I already started with that. Can you give me another angle that will create the same ray? Yeah, 30. So you would say 30 is a coterminal angle to 390. Well, usually you say the other way around because 30 is usually like your reference, but that's fine. You can say it, technically you can say it the other way around as well. And that's not the only one. You can keep going, like an extra 360, an extra 360, an extra 360. You don't even have to have a positive one. It could be negative. You could say this. You could say, what's this angle? Negative what? Nah, you're close. 330. You could say negative 330 degrees is coterminal to 30, and it's coterminal to 390. They're all related by this, Chavez. Why? Well, I want you to notice, guys, I'm going to color it here in blue, that if I do this, isn't that right there in blue, isn't that just one revolution? Yeah, so that 360n comes because that's one rev. And where n is an integer, well, n just means how many revolutions have you done. Does that make sense? And you can get them all that way. What was the question, Gonzalez? You forgot? Oh, I just drew, like I did the red one first, 390. And I said, can you give me another angle that creates the same ray? And yeah, I'm 30 degrees away from the x-axis. So if I did 30 degrees right here, I should have chosen a different color. If I did 30 degrees, let's see, can you tell burnt orange? If I did that burnt orange at 30 degrees, that would create the same ray. So that's what you call coterminal. All those angles are coterminal because they all create that same angle or that same ray. It's just a different rotary, like, you know, we've rotated a different amount, but all of them create that ray. Does that make sense? Are you guys feeling okay, guys? All right. I think we got it pretty cold. I think we got it stone cold. Now this is gonna really help you out. Turn the page. The reference angle is gonna help you throughout your physics career when you're doing tangents and normals. Check it out. So this, what does this say? It says the reference angle of an angle in standard position is a positive acute angle between the horizontal axis, so underline the word horizontal axis, and terminal side. Chavez, what's terminal side? Relax. Terminal side is just where it terminates, where it stops. Cool? All right. So what is a reference angle? So I guess let's start. So I'm going to draw a random angle. And I know there's an example 1 down there, but I want to do this before. So here's my random angle. I'm going to say that this is 120 degrees. Special angle. I want to know my reference angle. Well, this says it's a positive acute angle. So a positive acute angle means that my angle must be less than 90, but larger than 0. If you're at 0, then you have no angle. And it says that it's between the what and the what? Yeah, the horizontal and the terminal side. Well, this where I stopped, this you would consider that ray your terminal side. And what's your horizontal axis? This dude right here. Let me change the color. This dude right here in red. So that in red is considered your reference angle. Usually, not always, but usually, you will see a theta with a little subscript r in the bottom. That's how you say the little r is in the bottom subscript. And that little subscript stands for reference. Cool or not cool? All right, now, you guys are smart. How do I figure out that reference angle? I already know it's between 0 and 90 degrees. Look at me, not putting degree symbols. How? Yeah, why? Good job, miss. We know, we said earlier, you guys told me earlier, look, that axis was 180 degrees. So if you want to figure out that reference, you just take that angle, 120, and subtract it from 180. Cool or not cool? Now, it's the same pattern. Check it out. One more example, and then we'll go right into example 1 here. So here's my grid again, and give me a number between 180 and 270, any number. Okay, 195. That's fine. No, you said 195. You can't take it back. So here it is. This angle is 195. I made it kind of close to the x-axis because it's not too far removed from it. It doesn't have to be perfect. I mean, I guess if you would have done this one, I would have been like, but you're still in the right quadrant. So I would have probably counted it correct, just like, come on. Anyways, so there it is, 195. What's my reference angle? You're not going to do 180 minus 195. No, not 270, because the reference angle is always with the horizontal. It's with the horizontal. It's that one.
Negative 15?
No, remember, it's a positive acute.
Oh, okay. Oh, okay.
So that's going to be, you got the magnitude correct. Just 15, yeah. The reference angle is 15 degrees. So how did it change? Well, I'm in quadrant 3. So now I take this angle, 195, and I subtract the 180.
Oh, so even because like I see this negative 15 because I'm going backwards, but it doesn't really matter?
The reference angle is always positive.
Okay. And it's like the closest one.
To the x-axis. You see how?
Okay, but what if it was like smack dab at like 270?
Oh, well then your reference angle is technically 90. But they're not going to ask you that. I don't know. Because there's nothing exciting that really happens at the 90s, 180s. No, I'm not. Like, okay, like let's just talk physics. If we were talking 90 degrees and you're talking like one directional motion, you know what I mean? So nothing really exciting happens in one directional motion. We live in a 3-dimensional space, so really we should have X, Y, and Z, but we're not there yet. We got to get better with this first. Okay, last one. If I'm in quadrant 4, let's see if we can come up with a formula. So I'm going to do the same grid, guys. I'm going to go and write it like down here. I'm going to say that is 300 degrees. How do I calculate my reference angle for that dude? Yeah, how'd you do that?
Oh, 360 minus. Maybe I could have played that.
360 minus, can you guys see that color?
Yeah.
I kind of like it. 60 degrees. And it just depends where you're at to calculate that reference. It's pretty basic once you get the concept, but you got to practice. And if you're in quadrant, oh, I guess let's do that. We haven't done one in quadrant 1. I'm going to exaggerate quadrant 1. And I'm going to say, what's my favorite number? 50 degrees. What's my reference angle here? 50. It's the same because it's under 90. It's in quadrant 1. It's with respect to the x-axis, so it's just 50. So quadrant 1 is the same. Quadrant 2, you subtract from 180 to figure out your reference. Quadrant 3, you take your angle, subtract 180 from that angle. And in quadrant 4, you're that many degrees away from a revolution, so 360 minus your angle. Did I say all that correct? Hopefully I did. Hopefully when I replay the video, it sounds like yes, yes, yes. And if it's wrong, I'll note it. What's up? What's up, Gonzalez? Yeah, I'll put the formula here. You know what? Let's put them here. If you're in quadrant 1, as is, especially if they give it to you, right? If you're in quadrant 2, you're going to do 180 degrees minus your angle to get theta r. If you're in quadrant 3, always use Roman numerals for the quadrants. Then you're going to do theta minus 180. And if you're in quadrant 4, you're going to go 360 minus your angle to get your reference. That's if it's positive. If it's negative, you pretty much do use the same logic. All right, here we go. Example 1. Sketch angles. So these are the angles they want me to sketch. So here we go, grid. I'm going to exaggerate quadrant 1. Here's how you exaggerate quadrant 1. When I say exaggerate, I'm just like zooming in on quadrant 1. And then it says 71 degrees. So here's 71 degrees. Theta equals 71 degrees. And it says in standard position, so there it is, and calculate the measure of each reference angle. Okay, what's my reference angle on this one? Same thing, 71. We're okay with that one? All right, we got that one out of the way. Let's do 133. So I'm going to do a grid. Here's my grid. I'm going to exaggerate quadrant what? 2. So, I mean, you can put all 4 quadrants if you want, but I just want to focus on quadrant 2 there. And then I'm going to go ahead and draw 133. It doesn't have to be perfect. I'm going to say 133 is like right there. I want to see what the reference angle is. So my reference angle is this dude right here, theta r. And we're going to say that theta r is equal to 180 minus 133, which gives us, what was it, 47? 47 degrees. Is everyone okay with that one? Perfect. Let's go to the 254. So I'm going to draw a grid again. I'm going to exaggerate quadrant 3. So here I am, exaggerating quadrant 3. 254. I'm going to say 254 is something like that. Closer to the 270 than 180, but it doesn't have to be perfect. The reference angle is this guy right here in blue. And you're going to go 254 minus 180. 54, 64, 74. Did you guys get 74 degrees?
Yes.
Or is it 76?
It's
74. Are we okay, guys?
Yes.
So we got that one done. Let's do 317. 317. Oh, I wanted to exaggerate the quadrant. 317 is in what quadrant? 4. So there I am, exaggerating the 4th quadrant. And here is 317. Probably closer to the middle, but the middle, like splitting that in half, but I didn't do a good job there. That's fine. 317 degrees. The reference angle, well, look how close you are to doing a full revolution. You're that many degrees away. So you're going to do 360 minus 317. And that's going to give us 30, 40, 50, 60, 43. Yeah, I should have been right closer to the middle. I made it look closer to the y-axis and x-axis, but that's fine. No big deal. How do we feel? Do we feel awesome? Okay. All right. We don't got that many questions left. Example 2. Find each angle in each quadrant with a common reference angle with 204 degrees from 0 to 360. Okay, so now I'm going to draw all the grids. I'm going to try to go slow here because I don't want to confuse anyone. I'm going to try to use different colors. 204 degrees is in what quadrant? 3. So I'm going to say, let's see, something like right there. Not perfect, but that's fine. The reference angle is this distance here. So to figure out that reference angle, I'm going to do 204 minus 180. So we get what? Yes. All right, sorry. I'll slow down because I know that I'm probably speeding up here. All right. So here we go, guys. So I got my reference angle of 24, and I want to know if I've answered the question. Well, I don't know. I haven't read it fully to understand it. Let's see. Find an angle in each quadrant with a common reference angle with 204. So I found my reference angle for 204, which was 24 degrees. So what they want to know what's the angle that creates a 24-degree reference angle in each quadrant. Does that make sense? So I'm going to draw a 24-degree angle in all of them. So here we go. 24 degree. There it is. That's 24. It's symmetric about the x-axis. Make a linear line here. Connected to that burnt orange one. That's 24. And that's 24. Is everyone okay with what we did? All right, all I did, Gonzalez, is I made a reference angle of 24 degrees in all the quadrants because they want to know each single quadrant. You know what I mean?
But it doesn't change, right?
The reference angle doesn't change.
So it would just be in all of them.
And yeah, and now, so I'm getting closer to my answer. What they want is to find the what? Find the angle that creates that reference angle. So quadrant 1 is just 24 degrees. So you got an easy one right there. Which one did they give us? They gave us the one in quadrant 3, right? So that's the next one that I would fill in. They give us a quadrant 3 one, which was 204. All right, how do I find the quadrant 2 and the quadrant 4 one? Perfect. Subtract 24 from 180. So what do you get? 100 and yes, 56. Do you see how we did it, guys? All right, how do I find the one on quadrant 4? Yep. Take 360, subtract 24 degrees. 60, 5, 4, yeah, 336. And that's what they want. Can we do that, guys? Okay. We're just getting better at just angles right now. So I think we're doing a good job, guys. I think this has been so far the best class session from... Oh, I better delete that because then there's going to be beef. No, I'm just... It's going smooth. It's going smooth. All right, here we go. Ms. Davis, you doing all right? All right. So here it is, guys. Last one, and we'll take care of the radians on Friday, tomorrow. Sketch an angle of 4,897 degrees in standard position and calculate the measure of the reference angle. All right. All right, focus, guys. Gonzalez, Hernandez, focus, focus. So you can, if you want, you can do, actually Delta does it like this. They don't give you this big, but Delta does it 360, 720, and they make you keep going. Yes. But let's see if you guys understand number theory. So let's take out a calculator. Oh, any calculator will do it. So if you have a phone calculator, that will work just as well. Now, the big problem that we had yesterday, guys, is that kids were rounding because of the calculator, and then they were typing into the delta, and they were getting it wrong because they were off by a degree. So what I'm going to tell you is do not round. Well, Chavez, how do I do that? Let me show you. What is the amount that they wanted me to do? 4,897? So I'm going to type 4897. I'm going to divide it by 360. And I'm going to push enter. And I get a number. And almost everyone was able to tell me correctly what that 13 in the front stands for. That 13 in the front stands for what? Yeah, they did 13 revolutions. Are we cool? But almost, I don't think anyone got the 0.60. What does that 0.002777778 mean? What does it mean? So it makes an angle of 0.6?
No, it makes it 0.6.
No, it doesn't.
Oh, wait, no. Oh, it's because that's out of 100. We need it to be out of this to 60. So you would do like 60 over 100. It has to be equal to x over 60.
I think you're getting closer to where, I think if you're doing it. All right, guys. Let's go ahead and just talk. If someone tells you it takes you 3.5 hours to get to Dallas, does that mean, what does that mean, 0.5? Yeah, 3.5. So that means it's half of an hour, so 30 minutes, 0.5 times 60, right? So this, all right, time out. So this 0.602777778, what does it mean? It means that you cover 60.27778% of a revolution. That's what it means, guys. So let's make sure we're not robots. So how do I do this without rounding? Because I don't want to type all that again. Here's how you do it. I want to get rid of that 13. So I just go minus 13. And then I got my decimal, which means a percent. Do you guys see that? I take this decimal, which is a percentage, and I go multiply times what? No, not 100. 360. Because this is 60.27% of 360. And I push enter, and you're going to get a perfect integer. Do you see that 217? That's where you are located. Did everyone understand that, guys?
Yeah.
For sure.
Yeah.
That's life. Okay. 217. So where is 217 at? Quadrant 3. Here I am. Quadrant 3. That angle there technically is 217, but it's coterminal. It's also the same thing as 4,897. Cool or not cool? Every angle has an infinite amount of coterminal angles, yes. Are we okay right now, guys? All right, we haven't answered the question. It says it wants its reference angle. So the reference angle is 217 minus 180. Let's see, what is that? 20, 30, 47. So it should have been closer to the middle. I guess I did an okay. It's not 20, 30. Oh, yeah, you're right. I make mistakes. 20, 37. Yes. Are we okay? Yes, miss.
Is there another way to find the 217?
Oh, you didn't like that way?
No, okay. So honestly speaking, I found it a different way.
Yeah.
Easier.
All right, let's see.
So I did. I don't hear. Oh, okay. So when we got the 13 point whatever number, I did 13 times 360 and then minus that from that and got the remaining.
Yeah, you can do that.
Okay.
So what she's saying is this, guys. Oh, got you.
So I got.
And then you subtracted that from the original, which is the 48. Oh yeah, the 4897 is the original. Dummy. Not you, me. Not you, I promise. Me, dummy. 4680, and then she subtracted 4897 from 4680. 4897 minus 4680. And that's going to give you that number. Yeah, that's fine. It's the same. Whatever you find easier. You understand the logic, so you're good. Are we good, guys? All right, so this is what you have on delta. All right, so it's very sensitive. So check it out. Look at the first question here. And it says, what did it say? Estimate the given rotation within 10 degrees. So you see how it's just a circle and it just wants to know what angle that is. It's very sensitive, so you got to kind of reference. So here, take a picture of this. Or, yeah, show example. Take a picture of that. So you have an idea of where you're going to be placing. Did you guys get it? All right, so now let's go back to the original problem. So now look, guys, what does that look like to you? That looks like, it actually looks like a perfect 120, right? So let's see if it is. It might say like 119 or something. And look at that. It's actually 116, but I can't tell the difference between 116 and 120. So that's why they give you that tolerance. Cool or not cool? All right, so can we take care of this today, guys? All these?